Morning, everyone. Good morning. Can you all hear me? Anyone online? Could you give a thumb up if you can hear me? Thank you. All right. Yeah, let's get started. Very exciting to see so many of you gathered here today on a Saturday. We all know today, not just what's going to happen, what may be happening later today, miles away in Washington, D.C. But we're here to talk about a very important topic, which is the Smart Future AI Applications and Empowerment Forum. And this is our second seminar under this forum. First, let me introduce myself. I am Yingsha Yang. I am Vice President of the Greater Washington Entrepreneurship Club. And I'll just give a very brief introduction of the club, and then it's a Smart Future AI Application Empowerment Forum. And then I'll hand it over to today's host, our speaker, Kevin. Our club was founded in March this year. And the purpose of the club is to really foster an entrepreneur ecosystem in the greater Washington area. Through resource sharing, experience exchange, skills training, and project incubation, we strive to provide training, mentorship, information, networking, and funding resources. Those our goal is to empower more individuals to achieve their purpose values through entrepreneurship. Since our foundation, we have organized several activities, and one of them is this Smart Future AI Application and Empowerment Forum, which we hope that we can develop it into a flagship of the club. And the founders include of this forum include Dr. Hongjun Yang. He's too busy with the welcoming the audience, and Dr. Victor Wang sitting with us here, and Dr. Kaiju Tang, who cannot be with us today, but he is an expert in the AI area, and myself, Dr. Yingsha Yang. And we are experts in various industries, and we really share the same vision, which is that we are now living in an era which artificial intelligence is not just a concept of the future, but a rapidly evolving reality that's shaping industries, boundaries of what we thought possible. And therefore, we founded this forum as part of the club's efforts to promote innovation and entrepreneurship in the scientific application in the DMV area. And focus on different areas of AI application. And the first one is going to start with the pharmaceutical industry, which is not surprising given how prominent this industry is in the DMV area. So over the next 2 hours, we'll dive into this fascinating world of AI and exploring its application in this industry. And this will be a really fantastic opportunity to learn, share insights, and connect with the fellow experts to unlock the future of AI. So with that, let me introduce today's seminar host, Victor Wang. He is a serial entrepreneur, corporate executive, and a frequent speaker on the future of work and the societal impact of emerging technologies. He co-founded Entagel, LLC and worked at Fannie Mae for 15 years, leading the development of core financial model systems and providing guidance to industry and financial professionals. He's a member of advisory board of the Department of Applied Mathematics and Statistics at Johns Hopkins. He holds a PhD in system reliability engineering from Johns Hopkins. He is a leader in AI in the DC area, and we are honored to actually have him as the inaugural speaker of the first talk under the Smart Future Forum. And just last month, he gave this wonderful speech about the AI application in daily life. With that, let's welcome Victor Wang. Thank you.
Thank you. Thank you, Dr. Yang, for the kind introduction. Today, what's our agenda? Oh, go next. Okay, so today's agenda is as follows. We have a couple of honored guests. I'll introduce them. They'll make some remarks, and then I'll introduce Kevin, and then he will give our keynote talk today. Without further ado, the first honored guest is Stuart Redchick. Stuart Redchick serves as the administrator for the Asian Pacific American Chamber of Commerce and for its foundation, which today is a co-sponsor together with the Montgomery County Office of Economic Development. A former Chamber of Commerce executive director, Stu has for the past 40 years been of service to business leaders, innovators, and his community. Along with his wife, Jeanette, lives in Germantown. Let's give Stuart a warm welcome.
Good morning, everyone, and welcome, and thank you for this great opportunity to work with you on this special program. The Asian Pacific American Chamber of Commerce has been around for a couple of decades, and here in Montgomery County is where we're based. And we're very proud of our partnership with the Montgomery County Office of Economic Development, encouraging people to want to have businesses in this area. I know many of you are from Northern Virginia, as well as many of you are here. We truly live in a dynamic corridor of economic opportunity, and the pharma industry has made that very much possible. And I want to also let you know that we have a foundation, which is actually the official co-sponsor for today. It's an honor to be here. I welcome this and future opportunities to work with your groups. Very much.
Thank you, Stu, for your great support and community service. Next, we have another honored guest, Dr. Chao Wu. Are you there? So Dr. Wu is really a pride for our Asian American society. I'm fortunate to be able to call him a friend. Dr. Wu serves as a member of the Maryland House of Delegates for District 9A, representing Howard and Montgomery counties. Prior to this role, he was a member of the Howard County Board of Education from 2018 to 2022, where he made history as the first Asian American to be elected chairperson in December 2020. In 2021, he was elected to the board of Maryland. With a professional background spanning both the private and public sectors, Dr. Wu has expertise in data science, machine learning, artificial intelligence, quantum computing, cybersecurity, enterprise risk management, and the real estate mortgage and valuation model. Dr. Wu received a PhD in electric and computer engineering from the University of Maryland, College Park. He also holds a master's degree in electrical and computer engineering from the National University of Singapore. He has a Bachelor of Engineering from the esteemed University of Science and Technology of China. With that, let's give Dr. Wu a warm welcome.
Thank you. Victor, can you hear me?
Yes.
Okay. It's my honor to join your series seminar today. I think really appreciate you bring the expert together to really give our audience a much bigger audience and exposure to what's the latest advancement of AI. So I'm Maryland State Delegate Cha Wu from District 9A, representing Howard and Montgomery County. And I think my background, I have two hats. One hat is a Maryland legislator. The other one is a data scientist, as many of you here as well. So today I want to introduce something I think is important to the Asian American community about both expertise in technology and involvement in community. I know many of us here have been really helpful to serving the leader in certain capacity in our community, especially in technology. At the same time, I know it's really important to really present ourselves and get involved in the community events as well, because any policy change will have a huge implication in our community. We know that what's happening every day, right? Any policy, either from administrator or from administration, from the federal government or state government, or from the legislator like a Congress to make a law, anything can really impact the community, either from the recent decision about revoking Chinese international student visa, or like alien law in many other states, which impact our life. So technologically, we have the background, we have the expertise. At the same time, I think we need to get a little more involved is in policy and community. So for me, I will always think about what can we do with AI as a legislator. I think there are several parts of AI is really will impact us for the future. One part is regulation, right? We heard about recently Congress, they're passing a law about say state should not regulate AI for the next 10 years. That's a huge law, right? Or they say, and we're not able to export any advanced chip to foreign countries. That's another law, right? You can see every decision from legislature, from federal level can impact a lot of stuff. At the same time, either in Maryland or Virginia and DC, and many local states have different legislation as well. For example, I have an AI legislation about training data transparency. So we want to make sure when large language model and many other and they need to disclose where are the training data comes from, right? How do they prepare the data for training? Because we know training data is essential to the quality of your model. So we talk about MRM, right? Model risk management. So that's kind of our internal risk evaluation. But from outside, as a regulator, what do we do? And we don't have really standard right now, either from state level or federal level. So that's something I'm trying to understand and try to say, with my data science background, how can we make sure Maryland has a sound AI policy there? At the same time, we know AI can be really helpful to really provide values for entrepreneurs or for government or for many different parties. For example, if you think of AI for government, right? How can we use AI to deliver better service to our residents? How can we use AI to support government internal operations, both in terms of efficiency and accuracy and fairness? I believe AI can really provide value in that part. So the other point is think about AI for education, especially with a large language model, right? We know it changed the education. It will change education dramatically. So right now we know we have a challenge to provide STEM education to our from our public schools. We're lacking talents in the STEM education. So how do we use AI to generate content or deliver model to our students? Can we have really good tools, AI tools to improve performance? Can we deliver special education content in a different way, makes it more efficient and more more powerful? So the other part is AI for gaming, right? So I forgot to mention, I'm in Maryland State General Assembly. I'm in the Ways and Means Committee. So in my committee, we really focus on tax, education, gaming, and the election. So that's the reason I come back to AI for gaming. I think how do we regulate AI online gaming, right? You want to make sure the even is a game, is a gambling, is a fair gambling, right? It's not just a scam. So is there any AI tool we can regulate online gaming? And then across the borders, how do we regulate that? And that's something we have been thinking about it, and we definitely will have some regulation on that. So the other part is like, how do we use that to create gambling games, right? That's another one we feel will come out a lot. Last one, I think, for taxation, right? So for taxation, there are two parts. One is the revenue part, right? Which kind of service should we tax? Especially using AI. We know used to be a lot of services in person, labor, and now it's kind of everything converted to AI. So are we still able to tax them? And if we don't, where do we get the revenue? Because that part has been converted from labor to AI. And then how do we use AI to detect tax evasion? How do we really prepare business with a tax optimization strategy using AI? And then I think, is there any extra revenue and we can collect from the AI business? So you can see many from many different perspectives, AI has been impacted people's life and the government's job and the legislators' work. So at the same time, we know it's changing day by day, work by day, and from industry to another industry. So I really invite everyone who are interested in this. If you are entrepreneur, think about different angles you can do to really build build your industry, build your company. The other side, if you have any suggestions, feedback, how should we regulate AI, right? So reach out to your local legislators, like state legislator and the congressmen, senators, and that everybody are thinking about what can we do. And that will be helpful to really say, from technology point of view, you can contribute your technology expertise to the better good of the community. So I really welcome everyone to join the journey to get involved with legislation and the community service and make our community stronger and together. Thank you very much, Victor.
Thank you. Great speech, Dr. Wu, and also very relevant for our entrepreneur club. Not only you address some of concerns with rising of AI, but you also point out a lot of opportunities for our entrepreneurs to pursue. Thanks so much. We are so honored to have you here. With that, I want to go introduce our next speaker, our main speaker, Kevin Ho. Kevin is a dear friend. I've known him for a long time. He has accomplished a great deal. I just want to point out a few. Kevin is a very successful business executive in the IT and the financial service industry. He started his career at Fannie Mae. I was fortunate to have him working in my team. Very quickly, he demonstrated his exceptional talent, capability, and work ethic. With that, I was able to promote him to manager. And soon, I saw his potential, and I proposed, and Fannie Mae agreed to sponsor him to obtain an executive MBA from the Columbia University. After that, Kevin pursued merge and acquisition, other exotic career stuff at Wall Street. He later joined Capital One in a few short years, rise to director and later the head of Capital One's marketing and data technology platform. After that, Kevin was recruited by Red Venture to be their vice president for data. Red Venture is a global leader for consumer data and digital marketing. There, Kevin led a large team of scientists, engineers, analysts, and successfully built their revamp, modernized their data modeling and distribution platform. That is unbelievable accomplishment. We all know how hard it is to rise to that level, and he could have continued that track or live off that success for life. But Kevin, with his highly intelligent mind and deep expertise in AI, he foresaw that AI is a revolution and it's going to change everything. And he has to be part of it. With that, he courageously changed his career path and jumped into AI with both feet. 2 years ago, he started a company called AI and Human Harmony Consulting, using AI to conducting financial data analysis. Last year, he started another company called Medicine.ai to use AI to accelerate the drug discovery and development. I have no doubt Kevin will make a big splash in this AI revolution, just like he mastered finance and IT. So let's give Kevin a warm welcome. With that, Kevin, the floor is yours.
Good morning, everyone. Thank you here in the okay. Yeah, all of you making pressure time out of Saturday weekend time join today's session. Really appreciate it. So my name's Kevin Ho, as Victor mentioned. I'm the founder and the CEO of AI. Really glad and honored to be here to be the speaker talking about AI in the drug discovery. Again, I will thank Victor's very kind words. He was my manager for many years, gave me a lot of opportunity to grow during the years with him. And also want to thank the hosts, the creator of the foundation of the forum, which provide a platform for all of us coming together and learn from each other and communicate with each other. Yeah, it's really great honor. Without a lot of people's great work, this won't be able to happen today. So it's very interesting, right? We're having this in Rockville, Maryland today. As we know, Maryland is home of the finest life science research institute and the biotech and pharmaceutical companies. We have a lot of experts here in the room and online. So it's great. You know, you are all here because you see the power, potential power of AI. You want to be lead the curve ahead of many other people, which is great. Again, kind of repeat my today's topic is called agentic AI. you're
I just
truly
wanted to speak Chinese.
content, or even your whole virtual
Recording
team.
in progress.
So this is what I hope we can achieve together today. I'll share information at a minority with the group. First, introduction to agentic AI. Then we'll spend bulk of the time on doing the real demo of using the agentic AI on drug discovery. During the process, feel free to stop me. We can have Q&A, or we can do Q&A near the end of the discussion. So that's sharing part. Also, we know, again, so many experts, you are really the expert in drug discovery. While I'm sharing the platform for drug discovery purpose using AI, I want to hear from you, your feedback, how can I improve the platform, or maybe even figure out how my platform can help you to solve your drug discovery problem. Just layout, we'll have a quick introduction about the company, a little bit of myself, an introduction about the Gen AI, agentic AI. Then the meat of today's discussion is really on the demo. Yeah, I'll be quick about introduction of myself because Victor already said so many nice words, kind words about me. I have actually pretty mixed background. During my college years, I studied both chemistry and finance. When I first got here, over 27 years ago, I was initially on the PhD program for chemistry, which is a career path probably similar to many people in the pharma and biotech industry today. But later, my career, my professional life took a very interesting turn. I did not pursue a job in chemistry or pharma industry as many of my friends, my classmates did. I spent 20 plus years by combining my financial education and computer science degree in the finance and technology sectors. Rising through corporate ranks, I launched my own consulting company 2 years ago, as Victor mentioned, Human AI Harmony, which is delivering the machine learning and AI services. A year ago, I started my company, the second one called the Medicine AI, which is dedicated to develop. All right. People on the internet, Zoom still can hear me, right? So the Medicine AI is devoted to build a genetic AI powered drug discovery platform. A little bit about Medicine AI. We are a very young company, very, very small as of today, but we have a big dream. And our dream is to help reshape how drug discovery can be done using AI. Currently, our agentic AI-driven drug discovery platform integrates best-in-class computational and AI models. It's tuned with public and proprietary data. It has human kind of intelligence at expert level knowledge, but operates at much faster and much greater scale than any human or human team can do. We are particularly interested in working with frontier researchers and small, medium-sized pharma and biotechnology companies, because we believe that's where truly the innovation happens. All right, so enough about myself, my company. Let's jump into today's topic. So first of all, right, we all know what is ChatGPT moment. About 2 years ago, the world all of a sudden know, hey, there's a chatbot called ChatGPT, which can do answer all kind of questions. So a few years later, after ChatGPT moment, probably all of us by now have used AI at different levels. To summarize different levels of AI usage, probably one way to look at it, there are 3 levels. Level 1 is we use ChatGPT type of bots as a standalone tool. It's very powerful, no question about that. You give your prompt, the tool, the bot will give you answer, but then you need to validate the answer. Then you need to decide what to do with the answer. You need to copy paste, maybe just make decisions, make executions afterward. It's all after you, after the bot tell you something. So this is level 1. Level 2 is agent, autonomous agent. What the difference between agent and bot is, agent will do things almost like from end to end. You give the prompt, give objective, agent will analyze it, make plan for it, and more important, the agent will execute, and agent will take feedback, will adjust, give the final answer. So agent is more autonomous end to end to meet your objective. So that's the second level. The third level is beyond one agent. It's collaboration, a group of agents. Each agent in the group is dedicated, specialized in certain things, certain tasks. When all the agents come together, right, it can do much more than any single person or any single agent can do. It's literally forming a team. That's why we call, the agentic AI, multi-agent AI team is like literally is a team. It can do kind of team level work, organization level work. This is just make sure when agent, people with different backgrounds, with different level of understanding, familiarity with AI, some probably know agentic AI pretty well. Just for anybody benefits, let's stay on the same ground. Let's understand what we are talking about when we talk about agents and agentic AI. If you look up dictionary, this is what you get from dictionary. It can be a government agent or somebody doing like executive, somebody doing some special thing is an agent. This is literally dictionary definition of agent. If you pull up the dictionary. In practice, think about this. I think all of us are agents, no matter what you do. You can be a scientist, you can be a doctor, you can be a business analyst, you can be exact. In the end, we are all agents because we are specialized in certain things. We can look at information, we make decisions, we take actions, we correct our actions, and we achieve our goal. That's what we do as highly trained professional. We literally are all agents. So understanding what agent is, agentic AI or AI agent is easy to understand. Basically, it's just the AI paradigm or AI system does what humans do. And it's trying to mimic humans. So, and when AI system is trying to mimic humans do, you need to do what humans do, right? What we do is we observe, we receive information, we understanding our surroundings, our context. Based on that, we make a plan, we do reasoning, then we take action, we take feedback. Again, it's pretty kind of straightforward, easy to understand how we solve problems as humans. And that AI, agentic AI, basically does try to mimic what human does. If agentic AI can do that, basically it becomes autonomous. You don't need to tell it what to do step by step. You just establish a goal, objective. AI will pick it up for you, do it for you, and make correction, improve for you over time, become adaptive, getting better and better. That's good AI, even for human. If you can do that, getting better every day, you are a very effective person, right? You're growing. After some like concept introduction, let me give you one real concrete example. I actually just take liberty of taking one real example that Google announced in Google I/O 2025. This is one agentic AI service that Google is going to launch with many other services they are going to launch. In this particular example is the AI agent help somebody do apartment search. Again, I literally copy paste the prompt that Google CEO used during his presentation. Because this is the apartment search prompt. The user saying, hey, I'm looking for apartments with my 2 roommates during the time frame with a certain budget frame and certain requirements on laundry or walking distance, so on and so forth. That's what the user provides to the AI agent. Then Google's AI agent will understand user's requests, then say, okay, I'll understand you. In order to do that, I'll do A, B, C, D, which means I will search apartment based on criteria. I'll show you the options that meet your requirements. And even more, I'm going to schedule an appointment for you. At this point, user can say, that's great, let's do it. Or user can say, let's go back, adjust the plan. Either way, you can see that agent already knows what a human wants. Agent has a plan, execution plan going from A, B, C, D to the end result. So then the agent takes action, right? Agent go to Zillow, go to all the websites, get all the information of the apartments that meet the user requirement. Then finally, in this particular case, the Google agent will also make appointments for the user. This is kind of, that appointment can be virtual, can be in person, but in order to do that, the agent needs to understand several things. What does the user's calendar look like? And what's the visibility of the apartment, like landlord schedule look like? Then make things happen. Schedule the visit, right? So this is one example along many other examples Google talked about during their Google I/O 2025. Those are coming. So I guess by this point, you already know that just, AI, agentic AI is very useful, very powerful. Particularly when a certain task is not one shot, it takes many steps. And sometimes also very information intensive. Think about apartment search. It may take many hours get it right? So information intensive, complex steps, maybe multiple steps. And this is the use case for agentic AI because the bot cannot do it for you. But agentic AI can do it very, very well. Another thing for humans' perspective, when we deal with complex tasks and a lot of information, some of us can do it, some of us may not super at it. Even we can do it, you will ask yourself, is this something I really enjoy doing? Do I really want to spend many hours just search apartment? Do I want to spend many hours just search for plan for my next trip? Right? So even you can do it, probably why not let the AI do it? Because this is a boring job, right? So let the agentic AI do it. Yeah, I think no matter we want or not, we know all the tech companies, they are racing to offer the services using agentic AI, touches every aspect of your life. traveling, shopping, education. You don't even need to ask for that. They will give to you because that's their business. They want to reach out to millions, 100 millions, even billions of people, right? That's what all the time. It will come to us. We'll get all those back, right? And for our community, for today's discussion, I think what needs our more intention is how we apply AI, agentic AI, to our core business, to the industry, to our science, research, discovery, because this matters more. Why? You spend 8 hours a day at least go to work. You work for your employers, your companies, and you make a living of what you do 8 hours a day. And your employers, your companies need to survive to be good enough to stay in the business, right? You get a paycheck. So, and now it's at the very critical moment of agentic AI, because whether somebody as a worker, as an employee, or whether a company can adopt agentic AI will be critical, will be determining factor. Because if you do not do it, your competitors do it, they will run much faster ahead of you. You cannot even see their back, right? You're out of business. So that's why it's critical. And that's why our focus, today is particularly on the discovery, drug discovery using AI. So let's move on to the drug discovery of using AI. As I mentioned, my company, Medicine AI, we are devoted to develop the agentic AI solution for drug discovery. And here is a very high-level overview of how the system looks like. We have many agents in the system. So obviously, this is the multi-agent system. And all the agents coming together, they have their own specialties. Together, they are a team. They do a team job. They do a company job in terms of drug discovery. To do the job, AI agents, again, need to understand humans' requests. You tell AI what I want to do. And the AI need to, actually, agents need to invoke tons of tools, right? Take tons of actions in order to meet user requests, such as AI agent need to query data, run simulations, run predictions, then get visualizations, generate a report. I think this is very critical differentiation of this AI agent versus what I showed earlier on the daily life agent. You know that for daily life agents, you do not need a PhD level to do the job. You do not need to run a simulation to do the job. Anybody can read, everybody can, have human basic reasoning capability can do it. But for this kind of scientific a very complicated, very sophisticated level of understanding of the domain knowledge in order to execute the job. Oh. All right. Hopefully not too loud, just enough for everybody to hear. Okay. Yeah. Previous page showed a diagram, showed different AI agents. This is just a mapping of AI agents to humans, drug discovery teams, get a sense of why we need those agents, AI agents, and in real world, how they map to real world roles, right? Take a couple examples. We have AI planning agents. In the humans role will be program manager or project manager. We have target identification agents. In the human teams, you have the target identification scientists, maybe bioinformatics scientists. You have ligand screening agents for AI, molecular design agents, admin prediction, so on and so forth. This is a long list. I'm not going to read it through for everything. But you can see what AI agent does really map to one role or multiple roles in the human's drug discovery team. That all the roles, as mentioned earlier, very specialized, very advanced education, very specialized skills required. All right, now we're done with introduction. Let's move to the demo part. The demo, I will first introduce the disease of interest. And then we're going through the demo, which takes 3 different modes: interactive mode, autopilot mode, and full self-driving mode. When we come to that stage, I'll give more details of each mode. I know for people in the business of drug discovery, you know this so well, right? But I just share the knowledge a little bit with people who are not in the business. I want to thank Dr. Harry Young, give me the idea using this case for demo. The reason of using that case as demo is we're not disclosing any confidential, any business secret. We're using this well-known, well-studied disease, and there's a lot of facts, there's a lot of results, particularly for those people in the business. You can validate against AI predictions. You can see whether AI is selling something, telling you something sensible or nonsensible, reasonable or not reasonable, because we have ground facts as fact check. So the first disease for demo is lung cancer, particularly the non-small cell lung cancer. It is the second most common cancer in the US adults. Even though new occurrences have been declined over years due to prevention and early diagnosis, but the number of death and death rate, if eyeballing it, about 50%. It feels actually very, very scary and very, very concerning still. The second case we're going to use demo today is around breast cancer, and particularly about ADC. Again, for people who are in the business of pharmacy, you hear this every day, probably many times a day. And just for knowledge, for people who are not in the business, ADC consists of 3 components. Part 1 is antibody, which will identify and kind of bind to specific antigen expressed by cancer cells. So that's component 1 in ADC. The second component of the ADC is a linker. It's a chemical molecule. What the linker does is it will help to connect the antibody with the toxin, the cytotoxin, which is payload, or somebody called warhead. It's like a bomb, right? Once the antibody attach the cancer cells, later the toxic chemical payload will get into the cancer cells, hopefully then kill the cancer cells by different mechanisms. So together, the antibody, linker, and the payload together makes one ADC. So why we're doing ADC? Because it has advantages. The antibody will go after a particular antigen expressed by cancer cells. With that, you're eliminating hopefully the side effects, because the chemicals not just go up all the cells. Some of those could be healthy, normal cells. Another magic of ADC, desirable feature of ADC is some of those medicine may not get into the tumor cells itself, but will be kind of, help to kill surrounding tumor cells. That's called the bystander effect. So that's advantages. That's why people all the companies now going after ADCs as kind of magic, precise medicine treatment. But it's not easy because you're dealing with three things. You need to make sure the antibody is working. You need to make sure linker and the payload, they are working. And more importantly, when you assemble all three things together, you are changing the structure, you're changing the property, and things work in isolation do not guarantee they work when they combine together. So it's not really not easy to make the ADC work. You have to conquer a lot of hurdles, a lot of difficulties. And then we particularly we're going to talk about two generations of ADC, TDM1 and TDXD. Those are particularly effective for HER2 positive breast cancer. Again, lay the context for people who are not in the business. Breast cancer statistic here, HER2 positive represent about 13% of all the occurrences. But this is a more aggressive breast cancer. Okay, that laid the foundation for the like disease and kind of background. We're moving to the demo portion now. So demo, we are going to have three modes, right? The first mode is interactive mode. Will be interactive visual. And the second mode is the autopilot mode. It will do things from end to end based on your need and show the results, do the self-correction, but less interaction than the interactive mode. The level 3 mode is FSD. Basically, what you do is give very high level goal, objective to the system, and system will figure it out and do the things for you. I think this is the most probably ambitious mode in terms of utilizing the agentic AI. I probably, from this point, I'm going to switch between the PowerPoint and the browser where I'm going to launch the program and do the live demo. Stop share. Then I'm going to share this. No, not this one. Too many.
What time, baby? Good. What time?
This? No, this is yeah, this. I don't know why it's still. Okay, stop. I see. Okay. So we're switching the screen to be shared. Just bear with me for a second. All right, so I hope the people on Zoom see the same screen as I'm seeing now. Is the drug discovery platform. Okay, cool. Yeah, back to our demo case. We want to look at non-small cell lung cancer. This is the interactive mode. On this screen, we'll take several steps. First, we pick the disease we want to analyze. Second, we want to use the system to tell us what targets are associated with the disease. Thirdly, we want the system to tell us what compound or ligand are associated with those targets. And lastly, we want to evaluate whether some of those ligands or compounds can be a cure for the disease on certain target. So it's kind of 4 steps process. Is, as I mentioned earlier, is interactive, is kind of visual, but this is our like stage 1 demo. So this database is actually pretty comprehensive. It's all the data, yeah. Let's say you want to see any, any disease, right? You just type in a few characters here. It will actually, it will kind of, pop up, right? So let's just focus on the non-small cells. So yeah, this is this disease we want to take a look. We pick the disease. Once hit the search button, what it does is it immediately gives us the targets, which we know based on the research associated with the non-small cell lung cancer. So this is step 1. But just curious, I know a lot of people, you doing the research in this space, right? How many targets you will guess are associated with non-small lung cancer? Like any guess here? Other guess? Oh, I said something. Okay, probably one of my early slides released. Yeah, it's very astonishing number. Yeah, that's something like probably we'll like to talk about later. So this is really a long list of targets. Right, it's very amazing. So here, just take a quick look. Right here is the disease. There's some basic information of the disease. If you want to see more, this is not much. Just about basic information of the disease. But let's see. You want to take a look at the EGFR. For people in the business, this is most researched, most utilized the target for the disease. Right? If you want to say, hey, I want to understand a little bit more about this this target, and just click on the button, right? This tells you the sequence of the target, the protein, this amino acid distribution, composition. This is just the 3D structure of the protein itself, right? So similarly, you want to take a look at a different one, right? KRAS is offer more or less the same, same information. If you want to have a close look of what it is, right? This is, as I mentioned, this mode is interactive mode, is a visual mode. Okay, this step, we done step 1 and 2 for this interactive mode, right? We pick the disease. We let the system tell us how many targets are associated with the disease. The step 3 is we want to let the AI system tell us what compounds, what ligands are hitting those targets so that they can be potentially the cure for the disease. So that's the step 3. I'm just hitting find ligands. But I tell you, this probably take a couple minutes, depends on the internet speed. Sure, yeah. 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 Andy, that's very true. And actually, to answer that particular question, the second demo will answer that better. Oh, okay. Let me repeat the question. So Andy in the room, he was asking, hey, there are like so many targets out there. What are the kind of criteria of selecting or shooting those targets? Because all those targets, they are at the different stages. Some more better understood and some less understood, right? So I didn't talk much about here. Actually, there's a my first answer is we'll have a look on the second step of the demo. But to answer Andy's direct question is, yeah, they are at different stage, right? What the target development stage means. Some of those are clinical study stage, and some of those are chemistry, some are bio stage, and some of those are dark, right? So they are really at different stages. Not all the targets are equal, but then this is big question: how we select, how we prioritize those targets. That will be the next demo that I'm going to show with people here. I think we're done with previous step. So we asked the system, hey, you know, there are 3,000 targets there, over 3,000 targets there. Can you tell me how many compounds, how many ligands you can identify? You know, here is showing up to 5,000. But actually the complete answer is 100,000 interacting with those 3,000 ish targets. So showing the first 5,000 of those, right? But for now, again, be very clear, not all those compounds are drugs. Most of them are not, because most of them people do not fully understand. We haven't done any testing yet, but those are the candidates at the different stages, right? So you look at this column, it tells you if this is a drug. Most of them are not, but we do know them. They have different activity type. They are from different like journals, different publications. At least the people have made those compounds. At least people know some of those activities of those compounds, right? But now let's just focus on the approved drugs, not all the compounds, right? Just, you know, I'm doing the filtering here. When I click on repurpose only, what will return back is just the list of the drugs, not all the compounds, right? This is what they're doing now. Again, we're dealing with a very big data set here. Give the system maybe a minute and we'll refresh, filter the result. Those are only the drugs, approved drugs by FDA. Yeah. The question is, I click on repurpose only. So the question is, what does the system do? Does the system go search online or just do the local computation? The answer to that question is it just searched local database because I already have all the data by this moment in the computer system. Early on, it searched the database everywhere. But this step, we're just doing the filtering. We're filtering down from over 140,000 compounds now just to the drugs, right? So now actually it completes, come back with only the list of drugs. And for today's demo purpose, we cannot do everything, right? We just focus on the EGFR for now, because then we are moving to the next thing, which is, let me see, let me do a quick filtering. We pick a E. Okay, there are too many targets, and even for approved drug, there are over 100 of those. For now, for this demo, let's just focus on one particular target, EGFR, and let's just look at the approved drugs. Then let the AI determine what drugs are good, as a cure for EGFR for this disease. So this is actually the last step for this interactive mode. As mentioned, we pick a disease, we let the system tell us what targets are associated with it. Would the system tell us what are the compounds, ligands associated with the target? Then we let the AI to evaluate, score the compound in those particular case, the drugs, right? Now this step is pretty fast. So this is actually they're about, according to system, we have like 26 approved drugs on the target of EGFR. And the question we're asking AI, the agentic AI is, how would you rank those drugs? And this is like ranking order. I have to like kind of move back, forth, and horizontally. So this is a ranking order of AI's ranking. And how AI does it? Essentially, there are 3 AI models have been utilized to make the scoring. And then the composite score based on kind of weighted average of the 3 AI models give the final result, final score. And then basically the ranking here is simply based on the ranking of the composite score from 3 AIs. Just pause here, maybe show a couple of things here. So as people in the business, a very critical question is whether a drug is effective. Is you want to know, can the drug even go into the protein, go to the target at the right spot? Can get docked and get the actually, we are showing the screen here is a protein with a drug. Are people online seeing the same thing? I'm a little bit worried because sometimes, online is seeing different things. I need to share. I need to switch sharing from. Yeah, bear with me. I'm just trying to switch, share different screens so that people on Zoom and the people in the Zoom in the room we're watching the same thing. Okay, probably kind of a dark. Yeah. All right. Yeah, this is just an example that is we pick one drug, and this is through the very complex calculation, which tells us whether a drug can get into the pockets of a target. And when the drug gets there, what's the location, and well, how strong is the binding? How strong is the affinity? When you see negative number is good, and anything like less than minus 7.5 is kind of pretty at least moderate binding, and everything like -9 or -10 means very strong affinity. More negative energy is better in this case, right? And even a little bit kind of animation, how the drug get into the pocket, get to the target protein. Again, let me switch back to the slide, to the I think we're here. Okay, yeah, we're going back to here. Okay. Well, this is just one factor. You look at the affinity, but that's not all, right? Let's pick one example. Why this AI model think, this particular target, this particular drug has a score of 8 out of 10. So the AI model look at the data. Okay, so the AI model look at data, AI model look at different dimensions. What's the safety profile? What is the efficacy? And what is the pharmacokinetics? And what's the treatment potential, so on and so forth. So those are all the different criteria that the AI look at it based on all kind of information, protein, the drug, the molecule chemistry, and the docking, the binding strength, all those stuff. AI make that decision, but this is just one AI's opinion. We have 8 other AIs as well. Yes. Yeah. This is we are. Just give me a second. Try to switch to another screen. I'm managing to switch back to slides. I will continue to use the slides for some of those discussions. Where's my slides? Yeah, think back to the slides. Yeah, just moving fast on the slide, then I'm going to answer your question. Yeah, those are what we showed in the real demo. And if you look at the chemicals, you can also see the molecule, what the chemical look like, right? Just the chemistry information. So this slide is what I showed. Lastly, we have 3 AIs. Look at the same information. They make their Let's redo it. Let me see. This one. Sure. Let me see. Just give me a second. Oh, why? I can find out. I think find out. List. Yeah, we are trying to switch the sharing here. Just give us a second. Okay, great. We're back on track. Okay, cool. Yeah. So yeah, we're here, right, to answer the question. Yeah, the score we're showing here are the composite score from 3 AI models. So this is a very simple approach. When we have answers from different AIs, then one more thing is based on the AI model, this guy is ranked on the top. Again, people, if you are in the business, you know this is the 3rd generation EGFR TKI. At least, AI is, on this case, AI seems to be not that wrong, right? Just based on, information that its own logic, making the call. Okay. Yes. Maybe share. English is right? What do you see on this?
I think that one of the key demonstrated theories through the AI, actually the best result is the current pseudo generation that we have. And then we all know it's the best sales on it. But he didn't make that point. Okay. I think that through all these 3,000, all these, you can see the first generation AI, second generation AI, third generation AI. So now he demonstrated that the that fit on the third generation. So
They're not doing that.
From okay, why have the resistance all the cool.
It's okay.
Anyway, what's that? AI. So that is the point. I think it's through the this AI through the 80 AI is improving when you the all the screening you consider every different point get the final box. I think that's the point that we did. So, and it also could be
All right. Yeah, I mean, Dr. Yang probably summarized much better than I did for the previous demo case. I think now, yeah, in addition to that, AI ranked highest one is the best treatment for now on EGFR, which is good kind of validation from that particular result. I think even we step back, think more broadly. We know there are about 100 approved drugs for the non-small lung cancer. In fact, all the 100 approved drugs, they actually concentrated all of them just on dozen targets. Early on, we mentioned the system, AI system already tell us there are over 3,200 targets. As Andy pointed out, all the targets, they are not equal. Some are better understood, some less. But then the question still is, should we actually, even like compounds, we know there are like 100,000 compounds out there. In reality, we know the research, the real world, the approved drugs, very small set of targets, very small set of drugs, right? But the question is, now we have AI. For whatever reason, historically, financial costs, or the pipeline, or the specialty of certain companies, only small set of targets, small set of drugs are developed. The question is now with AI, should we think differently? Because we can really speed up, right? Large scale search, much comprehensive search, much in depth in computer before you spend time and effort doing the wet lab. That's probably something we should think about it. So yeah, I probably need to speed up a little bit. I will even probably, let me do this, okay? Because switching back and forth between the slides and the demo is kind of a pain right now. I'm just going to use the slides, kind of record the demo result rather than doing the real demo for now. The second case, we're moving to the autopilot mode. So go to the application. There are many boxes like those. Each box is one AI agent. For instance, this particular guy is doing the target identification and prioritization. And we have ligands, scanning, docking analysis, and new drug lead optimization, repurposing, a lot of those. Each box is one agent that specialized things, right? Now we're doing the use case, the demo case. We're not running demo, but I'm showing the slides, showing the results, showing the steps. So this is actually to Andy's early question. There are so many targets out there. How you identify, how you prioritize. So that's this particular use case really for that purpose. So what we do here is go to the interface of the AI. Again, you say, I want to look at the non-small cell lung cancer as a disease. You can choose as many targets you want. 3,000, just take longer. In this case, let's pick 10 targets. And you can provide more information or even certain targets you want to look at it, right? Not just based on the AI's ranking, you want to look at it. When the AI tell you what's about, then you hit start analysis. Doing that, I kind of report the result I did on my own. Those are the top 10 targets out of 3,000-ish. So this is what AI thinks, EGFR and ALK, KRS, those are the top 10 in the list. So how AI does it? This page, I will probably spend a little bit of time. This is a summary page, busy, right? For human, I'm going to explain a little bit, but tell you, behind the summary page, there are hundreds of files that AI analyze, make this summary page, okay? On the summary page, I use some numbers, use some color boxes, help us to organize the information a little bit. From 1 to 6, the 1 is the conclusion. Okay, because we say, okay, there are those ranking. Pick one example, which is EGFR. The AI model ranks EGFR highest. This is AI tell us why it think it's high. And the box number 1 is a conclusion. Again, 3 models have been used. Model 1 have 9.5, model 2 have 9.2, and model 3 is 7.56. And 3 models have different ways, but overall, this has a score of 9 out of 10. So this box 1 is a conclusion. So box 2 are different colors, different boxes. Those are different factors that AI consider in order to rank, in order to prioritize the targets. Those are factors on disease association, evidence, expression pathway, network regulation, structure, sequence, docking, or some clinical evidences. Those looks pretty busy, but the box, the color kind of indicates which category they fall into. So number 3 is the AI suggests what's the strength about the target. And number 4, what are limitations about the targets? And then number 5 are recommendations about what do you do with the target. And number 6 is AI also tells us, hey, for EGFR, I know there are 2,541 compounds. You may further study, right? Those are activity data and so on and so forth. This already look busy to us, but behind this busy summary, AI look at hundred files, probably million rows, right? From many different calculations to generate one summary page. So that's how AI does it. Furthermore, AI look at all the top 10 targets, have some recommendations, have some thoughts in terms of some strategies. So that was the target prioritization. Here, another thought, right, for reflection is AI look at multiple factors. AI does all the calculations. AI pull the data. AI do this, do that. Well, we know the target prioritization is critical for any pharmaceutical company. And when you do this, you literally need to recruit a lot of PhD level scientists, look at very different angles together, probably spend weeks, months on top of everybody's decades of education. You have PhD, you have in-house learning, you go to conferences, all this together help you to make a conclusion whether a certain target is meaningful or important to pursue. That's what the AI does. But if I run this, probably AI can make a conclusion in 10 minutes rather than weeks, decades of education from, for whatever effort takes, right? I think this is also AI doing things that humans can do, but just much faster. It's the thing to consider. Shall we leverage AI to more? I'll skip this case. I mean, this is another case is people know that for the lung cancer, today a very popular strategy called the combo treatment. Because physicians look at the patient's situation, pick one drug, maybe multiple drugs at a time, because there's no single drug hits all the 3 different targets. So for my own fun exercises, I ask AI, hey, give me the design for those kind of magic bullets, which will hit all the 3 targets, right? This is the exercise for that use. I'm going to skip it. So now moving to the second demo, second disease of interest, which is the breast cancer. Particularly, we're looking to something called the ADC. Earlier on mentioned ADC is a targeted therapy treatment Here we're taking 2 ADCs for HER2 breast cancer, which is a aggressive breast cancer. Those are 2 ADCs you can think about as 2 different generations. Again, for people you are in the business, you know very clearly each role represents some characteristics of the ADC, such as what is the antibody for the 2 drugs, the same antibody? What are 2 payloads, right? The warheads, they're different. What is the mechanism of action of the payloads? They're different. And what's the drug to antibody ratio? They're different. What's the linker? Cleavable or not? They're different. Is there bystander effect? One has no. Again, just for people online, look at the colorful picture, a little bit context information if you're not familiar with it. The blue-green Y-shaped thing is the antibody. And then we have the pink, little pink linker, and the red thing is the payload warhead. So you see here, there's 3, right? On average, as mentioned here, the ratio of drug to antibody is 3.5. So this is ADC approved in 2013. Another ADC on the right, more drugs because the ratio is 8:1. This is approved in 2019. So, yeah, now switching back to the demo stream. I'm just talking through the slide and recording. Yeah, one agent in the drug discovery platform I have is the evaluation scoring for ADC's potent. Give any combination. You can give any antibody, any antigen, any payload, any linker, any DAR, drug to antibody ratio. The system can tell you very, very quickly what's the likelihood this ADC combination will be potent. So this is a function of this particular AI agency, its capability. Because we want to use HER2 positive cancer as example. So go to the ADC like database, select those 3. Once you select any of those are more detailed information, the name of the ADC and the indications, target name, and so on and so forth. So basically we're evaluating 3 at the same time, right? And we have 3 blocks just like this for information. Then you click on score all. What happens is this agent tells you what you think about ADC's potency. 2 of them are approved drugs. This is 2019, the second generation. This is 2013, first generation. Based on the AI model prediction, both of them very, very likely to be potent. For the second generation, the potency likelihood probability is almost 94%. And for the first generation, the potency also pretty good, 91%. So interesting one is the middle one. I picked it because it was in the group, nearby in the data set. And this is a new drug application based on my AI prediction. This one is 59%. For people doing statistics, you often pick a threshold, 50% as a threshold, right? Everything above 50 you see is positive, is a potent. But below 50%, you cut off, see, it's not positive, it's not potent. But But when you get something 90%, you know, it's very confident, very positive. You get something 50%, 60%, you may doubt, right? You know, you may hesitate because it's really on the margin, on the borderline. So at least this is the AI model says, right? So when I was putting the slides a couple of days ago, I was wondering what the other AI thinks, what the Gemini deep research thing. You probably all have used the Gemini AI deep research. It's really great tool. It does not do prediction, but very good at aggregating information from everywhere and give you very deep research on any topic. So this is what I use. Gemini AI does deep research, right? To be clear, what the Gemini AI does is totally different approach from what my AI does. Because my AI look at the structure of the protein and the chemicals, make the prediction. It's a diffusion and a transformer model. But Gemini approach is data grabbing, large language model summarization. Gemini AI does not do any prediction like my AI does. But here is what the Gemini AI tells me about this particular new application, right? Again, it's busy. My question to Gemini AI is very simple. How you think about this new application can be approved in FDA? So the first box is seems to be pretty low chance. And then also there's a box about FDA in particular. FDA has concern, asked the company to address, but years later, the company has not addressed yet. And FDA does not disclose details about what FDA asked the company to do either. And the third box is European counterparts, EMA, right? It says they think that the benefit of the drug does not always risks, right? They look at this particular ADC in comparison to some benchmark, heroes therapy. They don't feel this ADC, given the risk benefit, does not seem to be justified, right? So again, it's different approach. Like I'm curious, what the Gemini think about this particular drug. Yeah. Yeah, there are many steps. Transformer is part one. Need to convert the protein body structure to some embedding to have attention mechanism, right? Transformer, the key part is attention mechanism. Then based on that, they're like combining the protein embedding, the payload, the linker all together. Then there finally is the neural network model to predict, given all the features through transformer, through embedding, how those features correspond to potent. So that's kind of training process. It's multiple steps. Yeah, that's how the model works. Yeah, I collect quite a lot of data that I have public information about their potency, right? Then train the model for. Yeah, I mean, another quick thought. I'll come and wrap up probably in the next 5 minutes. Then we have time for Q&A discussion. People in the business know that the time for preclinical development for one ADC candidate, which means you have concept to IND, right? It takes about 15 to 30 months. After that, you go through 5-6 years for clinical studies. Just for the initial phase is like almost maybe 2 years plus and minus. It's a long process. But why do we change the way how we do it? Because at the point, my AI, based on my training, based on my validation, I can see that the AI model in terms of potency has at least 85% accuracy rate. So you can play the game differently. You do not need to wait for 15 months, 30 months to do the clinical study. You do not have to limit your choice of ADC just a few because it takes time, take effort, right? The argument is you can put as many combinations of ADCs, use computer to screen for you, maybe hundreds of this ADC, thousands of this ADC, by combining different antibody, payloads, linkers, give you probably 80%, 90% confidence, good answer before you spend years effort doing it, right? I think this is another approach of looking at how to speed up the drug discovery. One more thing I want to show this because this is the FSD. I'm passionate about the FSD. So this is even more aggressive. Okay, what you do is we just say, hey, give me the drug, right? We're going back to the non-small cell lung cancer exists, okay, right? Give me the drug for that disease, deal with multiple targets, help me resolve the drug resistance. That's it, right? Then you hands-free, okay? AI will say, okay, I'll look at it. I analyze your request, and I have like top 20 or top how many targets you want to look at it. And I'll do this. I'll do the main path, a sequence of things. I'll do the drug repurposing path. I'll do the multi-target path. Do you agree with the plan? Or you want to modify it? Or just let the execute, right? So this FSD mode, you can give a very aggressive goal, very high level goal, let the FSD tells you the answer, keep the computer running, a couple days later, it'll tell you the answer. So yeah, so that's the FSD mode, very aggressive, but I feel that's probably we should shoot for. I'm done with my demo, just final thought, right? I think at this stage for scientific discovery or whatever you're doing, we are humans. We're very good at certain things or not so good at certain things. We want to keep ourselves to more creative part of the work. For those routine work, I think about 90% of those routine work, if you can define what the objective is, if you can describe what the steps are, if you can describe, hire another person doing the things for you, actually qualify for agentic AI do it. As long as you can describe the objective, right? As long as another human can do it, I believe at this point, agentic AI can do it for you. If you shift 90% of that work, what that means to you, one person becomes 10 people. You have a team now. You're not working on yourself alone. You have a team of 10 people. So the 10 people team, they don't need to sleep. They can do 24/7 as needed. Very importantly, no matter which PhD we have, we're just in one area. So this kind of AI can be on demand for any domain, biology, chemistry, computational stuff, on demand for you. Get the right skill at the right time. Lastly, I think that's part of a human organization. In general, very big problem. When you have two people working together, you know quite often, probably that's more efficient than you have an organization of 200, 2,000 people. Because when you have a lot of people working together, also a lot of systems involved, a lot of operational errors. You copy things over from one place to another, one system to another, one person to another. You're introducing humongous amount of operation errors and also miscommunication, because what you think is different from other people's things. When you have 200 people, all the message get lost, right? Purposely or unpurposely. So, but agentic AI really can do this much better. I think seriously, we should consider 90% of routine work shifting to agentic AI. As a result, all these factors kind of combining together, what we get is exponential growth, right? Productivity increase. This page is a very bold statement by myself. It can be wrong, but I'll probably share with the team just for take the liberty of being wrong. We are productive But if you use AI bot with you, the AI become a modify your work. But if you use agentic AI, basically this become exponential, right? So that's kind of, it's critical, at this moment. Just close this talk with Sam Altman, smart, right? It can be one person with 10,000 GPUs. Yeah. Yeah. So that's it.
Questions okay, we start questions out we'll see questions tonight as well.
Thank you. Very insightful talk. Question. This question is, of course, that the AI have hallucination, how computing work copy or more as fail. And lots of questions come up. You have to have the timing in your reactions before reaching the but you have the thinker for that. A lot of time it's not working. And thinker two did and also a lot of thick issues like LD, which is thick issues. And I think that would be a good part for this see whether they're thick issues.
Right. Yeah, I'll repeat the question for people on Zoom, just in case you cannot hear clearly. There are two questions. First question is about hallucination. What about AI hallucinates? How we deal with it? For this one, I give my thoughts. I have a lot of thoughts around it. The second question is about ADC. ADC, there's one part of ADC is it's a linker stability. Because before the ADC get to the tissue, the right place, what if the linker break, right? The payload released so early can be a disaster. This is actually very, very good concern. I have some thought on that, but I also have a lot of experts in the room can comment, can help me to make the answer more complete, more accurate. First, go back to the first question about hallucination. This is a question actually people talk a lot, probably 2 years ago, when the AI first came out. People label that as number one alert, awareness when utilizing the AI. To be honest, today, we have very good solution on hallucination. I'll talk more about that. But before that, actually, let me share a joke. Okay? What in the world do you think hallucinated the most? Exactly, humans, right? It's kind of sarcastic, but it's true. Okay, but later we'll come back to that. Okay. Hallucination was an issue people talk a lot 2 years ago. Today, why is it less issue? If you're working on production systems, there's many ways you can deal with hallucination. Number one is you will feed AI with trusted, curated information. There are multiple ways of doing it. Like even with technology changes, early days people do RAG, means retrieval augmented something. I forgot the exact acronym for RAG. And nowadays you can have very big context window, a minute, like 10 minutes the tokens, right? If you have the computing power. With that, what you ensure is the AI does not look at anywhere untrusted information. You tell AI, look at those information because they are highly trustworthy. They are reliable information. You look at those information. So this is number one to deal with hallucination in production. Another very powerful method to deal with, I also use in my case, my own application a lot is, we're now talking about multi-AI system regime. In the system, you probably do not just use one AI. As I showed you guys, I often use 2-3 AIs, cross-check answer. AI can debate with each other. AI can cross-check with each other. That's another mechanism to deal with potential hallucination by AI, right? So, and lastly, if we're not talking about production system, this is what I learned recently. And I think this is very powerful, very open-minded thought, which is some people look at AI, say, you hallucinate. You like, you kind of shrug off, say, you are useless, you're not good. Actually, one way, if you're not dealing with production, what you do is, when you see AI hallucinate, and you have time, what you do is you will ask AI, where do you get the information from? Why you think so? And I have different thinking. You let AI to explain to you why and how the hallucination happens. So why this is important? Because this is where the creativity comes, right? When we talk to some people, you say, oh, this guy is bullshit, hallucinate. But sometimes that guy actually is a genius, right? You do the same way with AI. It's, you really spend your time. If it's not a production system, you spend time with AI, you challenge AI, let AI explain to you. So even to talk to human, human hallucinate a lot, but some people are really genius, right? You can really they have crazy thoughts, but later turns out to be wrong. So that's on the first question. The second question is on the, linker, safety, stability. I think those things is very critical. In the end, whether ADC works or not, this is some also problem I'm working on, right? In addition to potency, I want to have AI model predict how stable, the structure is, right? All different index around the ADC, in addition to potency. In addition to, also kind of predict how it's going to probably go through the tissues, go into cells. I want to build a model around that. So make the ADC prediction even more useful, even more helpful. I know a lot of people in the room are the expert in pharmacy. I want you to share your thought on ADC stuff. I know it's hard. Everybody wants to do ADCs, right?
So there are some questions online, and one question is, will the reporting be available? Yes, it will be available on YouTube. I think later we can send an email for everybody registered about YouTube link. Yeah, and someone asked about this highly specific question: how to compute the AI score, evaluate affinity. I did protein dynamics simulation on server for 40 days. What does the AI score include? Affinity, safety, efficacy in vitro and in vivo? Yeah, maybe you can answer that question.
Yeah, there are many, probably the affinity is more than a simple AI model, right? This is very specialized computational models. And it depends on a lot of factors, depends on which model you use. Some model faster, some model slower, some model more accurate, some model less accurate. And also depends on your own computing resources. If you have a GPU, probably will be much faster than you just have a CPUs. And even GPUs, there are different grades of GPUs. And yeah, it's it's very different. For me, my computer has even with a single GPUs with certain optimization, I never experienced like taking 40 days to do the affinity calculation. I probably can get results in minutes, given my own setup. But that's why, again, infrastructure definitely very critical. More GPUs, 10,000 GPUs, give you answer in seconds. Right. So, what's the other part of the question, Victor? The scoring. Yeah, so for there are different scores. On ADC scores, I built very specific models, look at features, embedding, 3D dimensions, all those stuff. That model does the scoring. It's not any AI model, it's my own model I built to particularly predict the ADC scoring. Some other scoring, such as the target identification, prioritization. There are several layers of work. First layer of work is need to get the data, the target data, the compound data, the clinical study data, the pathway data, regulation data. For those data, I do not generate the data, but I pull the data from 20 different sources, right? Those data are the truth, at least published truth. I use those data. And another thing is the AI model that I have, some computational model will do the docking, will do the binding. Eventually, there are like 5, 6 different categories of data through 100 documents. I feed those documents into the large language model. I use several of those. My simple question is, you are the experts for drug discovery. I provide you all the information, pathway, regulation, network, binding. You tell me what you think. Because those large language models are not just large language model. They've been trained on the world knowledge. They have been using those large language models, take PhD level, doctor exams, different exams. Right? Those are very well trained. If you provide all the information, those models will give you the scores. So that's how I did with the target prioritization and the identification. So yeah, those, yeah.
A lot of people signed up on the group to ask questions. One quick question online, which I think everybody's interested. Well, what is AI model behind your agent, right? Is it ChatGPT?
I use for that particular model, I use multiple models because this is the way to deal with hallucination. This is the way you cross-chat. So that's even honestly, I'm kind of keep exploring new models as I need it, right? Yeah, so I think that's not the critical part. The critical part is, as I mentioned earlier on, doing the drug discovery is different from doing AI agents for apartment shopping, apartment search, or online shopping, because we need to use very, very specialized, sophisticated models to predict docking, generate another antigen, generate another molecule, right? Small molecules. Those today, again, for people familiar with the industry, for instance, the AlphaFold 3. AlphaFold 3 is AI model. It's not just another large language model. Alpha 3 is diffusion model, right? So for a lot of cases, when you do the drug discovery, new drug generation, or you do the antibody generation, we use diffusion model. It's a very efficient way of creating another structure. And by the way, diffusion model is also the model we use for generating picture, generating videos. That's what AlphaFold 3 does. AlphaFold 2 use structure model, but after DeepMind find out diffusion model is better, they shift to the diffusion model. So again, doing this kind of research work is beyond the large language model. Large language model is great, hugely helpful, understand all the human language context, but for the scientific research, it's not enough. You have to use very big set of very specialized AI tools, AI models to deal with. I wish I had that many. No, it's so like any making fun of me. Like how many people have we have 10,000 GPUs? No, we don't. That's my dream. Okay, hopefully with some people support, maybe one day we get 1,000 GPUs at least.
Hi, may I ask a question?
Maybe there another question in the room. I'll answer quickly. Then I'll take your question from Zoom.
Okay,
The question in the room.
could you repeat the question asked in the room? Because we cannot hear, please.
The question in the room is, I kind of demoed my system, right? The question is, what's the subscription fee for the system? So far, I've been working very closely with some research institutes, some companies. I can make it online very soon, very quickly, as a subscription-based service. But I haven't done it yet because I don't feel that is something I'm interested in doing. I'm not using AI just another service, another subscription. I want to use AI for results. What it means is I work with my partner very closely. A lot of times I notice that the system is very powerful, but the system has limitations. Often I work with my partners to quickly improve my system. In the end, what I want to deliver is I want to deliver the drugs. I want to help you deliver drug candidates. You can go to clinical studies. So that's my goal. I do not want to just publish a software, say, hey, play with it. It's a toy, That's not my goal. I want to have you use the tool. I work with you. We generate the drug candidate. You can go for your clinical studies. That's my goal. Yeah, free. Yeah. Oh, what's the online question? Do we have another question online, or was just asking what the question have been asked in the room?
Yes, this is Kening, and very nice talk. So I just wondering, well, maybe you already asked the previous question. Maybe my question is not real question again. But so my question is, what is the latest data in your database?
Most of data just real-time data. So
That's great.
yeah, real-time data, pathway, clinical study, all those real-time data.
Great, thank you. And another question, if we so you just said you want to work with the partner to find some target which you can do clinical trial. Will you be interested to work with people like me? They working on their study virus, but don't know anything too much about the AI. Were you able to, if we have some problem, hope we can use AI to solve their problem, and will you be interested to discuss that?
For sure, yeah, just send me email. We can work together. I think this is a very good question. This is what I want to do with my company. In old days, you are a researcher, you have a lot of ideas, but you cannot really do much with it. You may publish a paper, you then stop there, because in order to make things happen, you need a team of scientists with you on different roles, right? And some people do more, say, okay, I raised several $1 million. I started my own small company. Even with that, with a few $1 million, you can only go after one target or two. You can only do very limited compound to study at a time, because everything burns money. I think with my AI, I really want to work with people have ideas. We can kind of, push you very far. You have an idea, you have a target, we can kind of find a way to do as much as we can, scan a lot of, evaluate a lot of targets, a lot of potential compounds, design a lot of potential compounds, validate them in computer before you even spend a penny for web lab. I think that will really, really change the game, because it's, you have an idea, now the technology allow you to make your idea kind of, get along, push forward, go much further out.
One more very, very, very effective that data will be available. Just now, the biggest, try to ask the question. And you said that you are not going to initiate a subscription based business, and you are going to work directly with biotech and scientists for new molecule discovery development. We are such an organization. We do have very talented team for antibody discovery, linker payload discovery, and we have a lot bigger capacity team, to make all sorts of linker payloads, and it's all sorts of antibodies for the discovery new disease. I don't think that you will do this business today. I wonder, how you could collaboration with, industrial settings like us, leading ABC service company, so that we can work together more efficiently for the development of new ADCs and solve the lot of unmet need market.
Yeah. I assume everybody on Zoom can hear Jack's question in the room, right? If so, I'm not going to repeat the question. If not, I will summarize Jack's question. Okay. Yeah, Jack is asking, he worked with very big companies specializing on the development of ADC with a lot of partners. He was asking how my company, if we're not doing subscription-based service, how to work with, their kind of, business context. Yeah, I think, there must be a way to do it. The reason I'm kind of, do not want to do subscription at the moment, because I do, particularly if there are like hundreds of people, 1,000 people subscribing, I'm worried about I'm not being able to service all of them very well. Because they may use the software, they may see something be, not the way they expect, or I don't have the bandwidth to support all those 1,000 people, users, right? But if this is dealing with Jack, your company, kind of, if it's not a business, that probably is different. We can have, software delivered to your platform, and we work with you, and through you, we can work with many of your clients, and we can make the product more tailored, delivering the work that you or your clients want. The reason I do not want to do subscription, because I do not want people to get confused about how to use the software or treat it as a toy, then walk away. I really want to make sure that the the tool, the AI does what people want, eventually deliver results what people want. And this needs to be a very close collaboration with another company like yours. This probably will be easier to figure out than dealing with hundreds of thousands of individual users, right?
What is different? QSDR, all statistical methodology, is finished. What version of the top? Familiar with QSDR?
Yeah. The transformer model is there's okay. So the question online was somebody did a lot of traditional statistical method like QSAR, some affinity prediction using computational tools. The question is, how is that different from transformer model? The answer is they're different for different purposes. Even today, when I use AI, I still need to use QSAR model, certain affinity model, as part of the overall prediction, as part of the overall consideration of whether certain chemicals have certain desired properties. We're not throwing that away. We're still using it, but it's just one of the many tools, probably one of like dozens of tools that AI is picking up. And transformer is a special tool. Transformer is good for certain things. It's built for certain things. Large language model is built on transformer architect, right? Transformer, as I mentioned for ADC, because it has very important feature, which is called attention mechanism. What that means is when you put all the, let's say, proteins, right? The AlphaFold can do the protein forecasting so well is it's on the attention mechanism. When all the protein come together, one amino acids above another or before after another, when all coming together, it's not one thing determining the structure, 3D structure or the function. It's all the things before after coming together in certain arrangements makes a difference, right? That's where the transformer, the attention mechanism make a difference in the overall the AI modeling. But again, it's not exclusive. Certain models will be used for certain cases. In my system, I use all of them at different parts and different steps of the overall process to provide those intermediate results before we get in the final conclusion, whether target, whether compound works or not, right? So yeah, whatever you have been doing in the past, they are still relevant. We still need to do QSAR, we still need to predict admit, we're still, even AI is still calling those models to do certain things.
Maybe I last question. Since it's entrepreneurial club's activity, I asked some questions related to the staff. So what's the largest challenge when you set up your AI agency? It's the software, the modeling, the data collecting, or the hardware?
I would think that the hardware is not really a challenge, it's a limitation. More is better. That's for sure, right? I think about the overall myself benefit a lot from using agentic AI. My whole system is not just written by me. Honestly, the system, 90% of my system is written by AI. Okay, so during the process, I really see the power of agentic AI, even developing my own system. The challenge is it's kind of a you have to keep learning. Initially, I had certain ideas. I thought it's great. I do it, but when I talk to an expert, and they may tell me something different, right? For me, it's just recognition of what I'm doing, how they are relevant to real world applications, what do people care about, and how can make system really solve people's problems. So for me, I treat this as a challenge, but also I like this kind of challenge because this makes things useful, helpful. And that's also why I think, I want to use AI for results. I do not just use AI for another product, another service. This AI cannot do everything, but AI is powerful. We need to use humans' ideas, work with experts, make things work, deliver results. So that's it's something we need to keep working on, keep to conquer.
All right, Kevin, thank you very much for a interesting and stimulating talk. I see, you have generated a lot of interest questions online, offline. I wish your endeavor big success. With that, let's next. All right. Before we go, I just want to mention that this is the second talk and seminar in our first series. We have several series coming, but this is the first series. I last on May 17th. It was the first one which I gave today. Haven't talked about this. And the next one, basically middle of the month, every month, Saturday. And the next one would be on July 19th. The title would be from organ cell AI-powered imaging in drug development. I don't want to read through that, but it's all in drug pharmaceutical related using AI. And the speakers are very distinguished. Some of the talks will be given by speakers from China. Will be doing online, probably some using Chinese, purely just to make sure the China and the US side both can benefit. That's all. Any quick thoughts, closing thoughts?
Yeah, thank you, Victor, and thank you, Kevin, for such a great talk. I think we have all learned a lot today. I would only just close this by two things. First, I wanted to thank our sponsors, the Foundation of Asian American Chamber of Commerce and the Montgomery County Office of Economic Development. Thank you for your support. I also want to thank every organization that helped us to organize this, including SAPA and CBA, including the Hopkins Club of Innovation and Entrepreneurship, and including the Chinese American Association of Science and Technology, and of course our parent organization, US Sino Innovation Alliance. And also I wanted to thank all of the people who have helped to make this happen. It's really like a team effort, including all the technical stuff that needs to be figured out. So really appreciate it. And lastly, of course, thank all of you who came here, joined us in person, and also everybody who joined online. And thank you for spending your valuable weekend time with us. And I hope you really learned from this. All right, thank you with that, and we look forward to seeing you in future events. Thanks. One last thing I should mention, anybody who's interested in the club, we have a QR code that is on the screen on the left. You can scan it and join the WeChat group. And anybody joined in person, you can grab a one-pager we prepared at the front desk and understand more. And also for people online, you can scan the QR code on the right to fill out a survey. And we also have paper survey for the person who attend in person. Thank you so much.
现在其实这个东西，你比如说，你看我把它 stop 掉之后，再 share 我的一点问题。比如说我在 share，主要就是你不要 share screen，就 share，比如说你要 share 这个。share 这个给完了之后，你就可以再 share 这个笔记，这应该就很容易。这样。
但我觉得有一个问题就是你这儿是换过来了，但那儿没换回来。
对，这是错了，因为他搞那个，这是他这个 screen 的，但你这个 screen 的话，这个 auto 的一个 software，打算给你分。anyway，这个下回吧。
Thank you so much.
下回那个音响。
哇，这么多 comments 啊！这么多 comments 呢，还有。
这种话题。关了吧。
Recording stopped.
你电脑那个。跑不了。
他是用那个，妈的。